Hello and welcome back to our channel. In today's video, we are diving into one of our essential cybersecurity control in automotive world, that is secure storage. So we'll be discussing what secure storage is and its critical role in protecting automotive data and the key aspects you all need to know and how it's implemented. Plus, we'll cover some of the challenges faced in keeping vehicles information secure. Whether you're new to the topic or looking to expand your knowledge, this video will give you a comprehensive understanding of secure storage and its importance in modern vehicles. So, let's begin the discussion.
Okay, so let us start. Today we are exploring one of the critical aspect as mentioned by Bhumika, which is secure storage. With cars becoming more and more increasingly sophisticated, it is essential to understand how to protect the valuable data that the cars collect. So let us dive into what exactly is secure storage and why it is so important for our vehicle. As we know that the modern cars are packed with electronic systems that handles everything from engine control to the navigation and so much more. With so much of data being processed inside and stored, ensuring that this information is secure is the topmost priority. In context of automotive cybersecurity, secure storage is a fundamental security measure which is designed to protect sensitive data and information within a vehicle's electronic system. Think of it as a digital fortress that shields the critical data from unauthorized access and potential threats. Vehicles' electronic systems comprise of various components such as ECUs, infotainment systems, braking systems, and many more things, and many more electronic devices. Each of the systems can store a range of sensitive information, going from personal driver profiles to the GPS data and also some of the system diagnostics. The main purpose of the secure storage is to ensure that the sensitive data remains protected. This involves the information from this involves safeguarding the information from unauthorized access, tampering, and theft. Imagine what would happen if someone could gain access to your car's ECU data and manipulate the information. The risks are really significant. Unauthorized access could lead to data theft, where sensitive informations like personal driver details or the location history of the vehicle could be stolen. Tampering could compromise the vehicle safety, and hackers can potentially interfere with the critical systems. Secure storage addresses all this risk by implementing robust protection mechanisms. So, in order to achieve this, secure storage employs various strategies. Let us understand a bit more deeper. Now, I would like to ask Dharmesh to explain what are the key aspects for the secure storage and how it can be implemented in the vehicle systems.
Yeah, many thanks, Riva, for outlining the secure storage and its importance in automotive industry. Now let's see some of the key aspects for the secure storage. First one is data encryption. So before you store the data, sensitive information is encrypted using the strong cryptographic algorithms to make it unreachable to unauthorized parties. Second one is access control. So implementing robust authentication and authorization mechanism to ensure that only the authorized parties or entities can access the stored data. Next is tamper resistance. So using the hardware and software mechanisms to detect and prevent the physical tampering attempts on the secure storage devices. And the last one is secure boot. So ensuring that only authenticated and authorized software can be loaded and executed during the vehicle startup process. So we had already covered secure boot in our previous videos. So if anyone wants to look into more in depth, please watch our previous video on the secure boot. So link would be provided in the descriptions. Now let's see what all are types of data generally protected regarding the vehicle systems. So first one is personal information. So your personal data like user profiles, contact list, and location data, which is mostly used by the entertainment domain or telematic unit in the car. So which needs to be secured in order to this information will not falls under the wrong persons so that they can utilize them for further damage. Another is vehicle settings. So the information like customized preferences, driving mode, or calibration data, such information should also be securely stored within the vehicle system. Next one is cryptographic keys. This is very important because cryptographic keys are used in multiple security mechanisms for generating the keys and secure communication, authentication, encryption, decryption. So it is very important that these keys will be securely stored within the vehicle system. Then the software itself and firmware. So protecting against the unauthorized modification and the malicious code injection, this also should be protected. And the last one is diagnostic and maintenance data. So safeguarding the vehicle's health information and service records are very important. So now let's see, we see in the aspects, different aspect of the secure storage. Now let's see what are the different implementation methods available to achieve secure storage key aspects, whatever we discussed. So first one is software based security. So this includes the employing the encryption algorithm as access control mechanism and the data integrity checks to protect the data stored in the software component like operating systems or applications or within the database. Another approach or implementation method is security, hardware based security, which is one of the example I have mentioned here is secure hardware extension. So the secure hardware extension is an on-chip extension to any given microcontroller. It is intended to move the controls over the cryptographic key from the software domain into the hardware domain and therefore protected those keys from the software attackers. On right side the image you can see it's basically three parts. SHE contains three building blocks. One we can see as a storage area, RAM, ROM, flash, memory, etc. The second part is AES. It's basically the block cipher. Uh, it belongs to advanced encryption standard where the encryption, decryption, those type of things will be performed. And the third one is control logic connection. So this control logics will be the important part here in SHE, which will be communicating to your CPU and other microcontroller peripherals. However, it is not meant that this will be replacing the highly security solution like TPM, Trusted Platform Modules, which are specially designed chips for secure storing purpose itself. Uh, or cryptographic functions will be stored in that chip. Uh, but yeah, it's depend on the implementation architecture, which one we will choose in our project. So there are different, every method will have its advantages, disadvantages. So HSM will be used or SHE will be used or TPM will be used. It's very between project to projects. Now third implementation method is data segmentation. Dividing data into different security levels allows uh, more granular control and protection. For example, critical data can be stored in the secure enclaves, while less sensitive information might be stored in the less secure storage devices. So, while designing or while implementing, certain data will be, you know, that this is security relevant as we discussed earlier, what type of data we can consider as security relevant. There are also some data which is not security relevant. In those data, you can decide and then further divide like which one should go into secure device or which one should be kept as it is. So yeah, that is the third method, and the next one is secure boot and update mechanisms. So this is also important method because this mechanism ensures that only trusted software and firmware can be loaded onto your vehicle systems while startup. So reducing the risk of malware or unauthorized modification. Now you may have heard or seen many times while you are exploring about the different security measures within the automotive cybersecurity. HSM term comes a lot in your reading or wherever you trying to explore. Somehow this HSM will be involved. That is because HSM used in multiple various use cases. It is also used for secure storage. So now let's understand how it works. So HSM is a subsystem within a microprocessor or microcontroller. You can compare this to additional processor core in the microcontroller application itself or our device itself. So on picture, you can see that it's a separate core for HSM and it has its own RAM, flash memories, which are protected from access from the rest of the other system. So in figure, you can see AutoSAR system, which is separated from the HSM core. The HSM offers the best solution for separating and protecting the confidential content. Now, HSM, as I mentioned, used for different use cases. One of them already I mentioned, secure storage. Uh, Another use case is there for the secure boot purpose. So during the secure boot, the authentication process will happen. This also can be handled via HSM. Also, one other use case is cryptographic acceleration. So there is so much activity when you encrypt the data, decrypt the data, so much load on the software side if you are doing. That's why HSM will help to accelerate this process because it has enough memory and computational power to just do this kind of algorithm, cryptographic algorithm, faster way. So this is another use case where HSM is used. Okay, now let's see how this HSM is integrated in the Autodesk system. In the image, you can see different modules available in AutoSAR system. The basic software module uh, provides the different services uh, like such as bus communication, diagnostic, or memory management services. Also, it is interact with the CSM module. So CSM also provides the different services. So in figure, you can see the cryptographic service API and also the secure storage API. So cryptographic service API contains the different cryptographic algorithm AES or generating the MAC or hash or random number generation. uh, and also secure storage. So as we discussed, like key and certificates needs to be stored securely. So whenever this CSM module will request, then it will be the responsible of the lower module where the crypto drivers will come into picture. So again, there are two drivers. One we say the crypto software. So crypto software is basically uses the software library to realize the whatever the service requested by CSM for the hash value or random number generation. So this all will be handled in software, which is done via crypto software module. Whereas the crypto hardware module will internally use the HSM to perform or realize this services requested by CSM. Important thing here notice is when secure CSM request for the secure storage, writing the keys or certificates to the memory. Directly, it will interact with the HSM hardware, and it will store, and while retrieving also, it will request and retrieve from there. So this is how HSM can be integrated into the AutoSAR system. And also this HSM will be utilized for the secure storage purpose. Now, apart from this, there will be also some challenges regards to the secure storage control. So Riva can explain about the challenges what are there for the secure storage.
Okay. Uh, yeah. So as we seen the implementation part of the secure storage, various methods. Implementing the secure storage in automotive system isn't just about uh, setting up a few security protocols, but it also involves navigating a complex landscape of performance, cost, compatibility, and ongoing maintenance. Let us break down this in challenges into one by one. The first one that we have is balancing security with performance and cost. Secure storage solution often requires advanced encryption and protection mechanisms. While these are essential for safeguarding the data, they can also impact on the performance of a vehicle system. For instance, the encryption process can introduce latency or may require some additional processing power. On top of that, the implementing the robust security measures can be costly. Automotive manufacturers must strike a balance between investing in high level security features and also maintaining the cost efficiency. Uh, the next point that we have is ensuring the compatibility with the legacy systems and components. uh, as we know that automobile often feature a mix of new and old technologies. Integrating this secure storage solution into the legacy systems can be challenging, as the legacy systems may not sometimes support modern encryption standards or secure protocols, which may lead to potential vulnerabilities. The next one we have finally is updating and maintaining the secure storage mechanisms throughout the vehicle's life cycle. As we know that the vehicles are not static and they need to undergo regular maintenance, software updates, and even sometimes the modification some modifications throughout their lifetime. Keeping secure storage mechanisms up to date is essential to protect against emerging threats and vulnerabilities. So, manufacturers need to implement the processes for regularly updating the security features and ensuring that any new software or hardware additions are compatible with the existing secure storage solution. So these are some of the challenges that highlights the complexity of protecting sec- protecting the data inside a modern vehicle.
Since we saw the implementation of secure storage, I have a question related to that. So, what are the potential risks if secure storage is not properly implemented?
Hmm. Yeah, that's a good question. And if I may answer, so uh, let's imagine you have implemented all the security measures like encryption you do on the data transmission, you also protected secure boot part, and some other control mechanisms at different level you have implemented. Now for encryption, suppose whatever the cryptographic key you use and it is not securely stored, then whichever the implementation you do or encryption you have done, uh, that will go waste. Means anybody can exploit using the storing this key which you use for encryption, and then they can read the data, and that's how they will attack on the system. So even though you have certain security measures available, you have to make sure that it is also important that secure storage also will be included. That's the reason why we have layered architecture. So if suppose one layer is broken, then also you have some security mechanism to prevent attacks, or it will safeguard whatever you want to safeguard in your system. So it is very important that security controls when you implement secure storage also uh, keep in mind and also should be implemented in my opinion.
Uh, yeah, so we have discussed about secure hardware extension, SHE and SHM. So when shall we use which type of hardware security modules, or when shall I use the HSE or HSM?
Hmm. Yeah, that's the interesting question. So answer to your question, I would say it's depend on the requirements and also whatever the uh, hardware you have available and which type of the implementation resources you have. Based on that, you have to decide. Generally, SHE will be the separate component, just extension to whichever the architecture you have, and there you have it's allocated some memories for RAM, flash memory. But for hardware security module, it will have separate core which will be allocated, and you required for extra storage or some extra resources to implement the HSM. So if of course it is more costlier than the SHE, because SSE will be still in your same architecture. You will use some part of memory and AES implementation within your architecture. The HSM, you should have a separate core and also resources for that. So yeah, I would say it's pure depend on the requirements what you have, and also keeping the cost in mind. uh, architecture architecture guy has to decide like which one to choose for the implementation.
Yeah, I have one more question. So as we seen, like we have different hardware supports to implement the secure data storage, like SHE or SHM. So how can we implement secure data storage without using these hardware modules? Are there any possibilities?
Mm, yes, there are possibilities. So if you don't use any hardware for your secure storage, then using the data segmentation and also implementing some of the restriction on your available memory, flash memory, or uh, the ROM, where you will then additionally feature you provide some more encryption on top of that, or authentication you can provide. So then only this memory will be accessible. So in software you can implement those type of secure storage mechanism. If you have hardware, yeah, then utilize the hardware to do this. But answer to your question, yes, it is possible. There are some methods using which we can implement secure storage without specific hardware also.
So, thanks for sticking with us to the end. We hope this dive into secure storage has given you a clear understanding of its significance in automotive cybersecurity. If you found this video helpful, don't forget to give it a thumbs up and subscribe to the channel for more insights into automotive cybersecurity and technology. Until next time, stay secure and see you in the next video.